Okay, so if you're watching this, this is actually example 2 of how to use the graphing calculator to solve systems that are not linear. Okay, so first example, we did a parabola and a line. This time, we're going to do something a little different. My first equation is x plus 1 squared plus y minus 3 squared equals 8. My second equation is y plus 3 equals x squared minus 2x. You may recognize that second equation because it's just the same parabola we used in our last example. Remember, I know this is a parabola because it has a y that is not squared and an x that is squared. Now looking up here, notice that both the x and the y are squared. Another clue to what's going on is that they're being added to each other. They're the same sign, in other words. This is a circle. Okay, so the first one, we have a circle and we have a parabola, so we're looking for the intersection of a circle and a parabola. Just to review, the steps that we go through to do this are the same every time. Step 1 is going to be to solve everything for y, so that all my equations are in y equals format. Step 2 is then put them in the graphing calculator. That's why I need them equal to y. And step 3 is to use the graphing calculator to do intersect, to find the points of intersection. Okay, so first step here is we've got to get this in y equals form. So I'm going to take this one over here. We actually just did this last time. It's a horrible, horrible arrow. We did this just a second ago. We said that y equals x squared minus 2x minus 3. Okay, that's simple enough. Now this other one is going to take a little bit more effort because it's just a little bit more complicated equation. So if I want to get this to where y is by itself, first thing I'm going to do, besides rewriting it, which is what I'm doing now, is I'm going to remove the x plus 1 squared from the same side of the equation as y. So I'm moving this by subtracting it. So now I have y minus 3 all squared, we say quantity squared sometimes for that, equals 8 minus x plus 1 quantity squared. Now the next thing I need to do to get y alone is to get it out from underneath that exponent, the squared. So I'm going to take the square root of both sides. So on the left-hand side, that's going to give me y minus 3. Okay, resuming after a brief intermission there for our interruption from the PA. Took the square root of both sides, and I get y equals 3 on the left. The square root symbol basically just lifts this 2 right off, lifts the squared off. On the right-hand side, I can't really do anything with this. I can't simplify it, and even if I could, it really doesn't matter. All I'm trying to do is get y alone so I can put it in the calculator. The calculator doesn't care how messy or unattractive the equation I put in is. So now I'm going to add 3 to both sides. Notice that I'm adding 3 after I have taken the square root. So the 3 is not up underneath the radical. So I have y equals square root of 8 minus x plus 1 all squared plus 3. So my two equations that I'm going to put in my calculator are here and here. But wait, there's a catch. When I take the square root, I have to account for the possibility that it could be plus or minus. Okay, and this is also something I'm doing for the calculator because the calculator cannot graph a function. That is, a calculator cannot graph something that's not a function. Sorry, it can graph functions. It can't graph non-functions. So it can't graph anything that would fail the vertical line test as one piece. This is a circle. A circle would fail the vertical line test. So what we have to do to sneak it by the calculator is graph it as the plus part, which is the upper half of the circle, and the minus part, which is the lower half of the circle. So basically what I'm doing is I'm graphing like this, two pieces, so that the calculator doesn't realize it's a circle. Now what that means for my graph here is that I'm actually going to put in 3 equations. I'll put this one in y1, and then this one is going to go in y2 and y3. Okay, so let's go ahead and go to the graphing calculator. And when we go to the graphing calculator, here we are at the home screen. I'm going to go to the y equals button right up here to input my equations. And the 2 equations, I'm putting in 2 equations, but I'm really putting them in 3 places. Were, first of all, let's see, y equals x squared minus 2x minus 3. Chances are we could have just left that one in from last time, but that's all right. X squared minus 2x minus 3. Now, in y2 and y3, we're going to input this other equation, because remember, we have to sneak it past the graphing calculator by calling it a 2-part equation. I'm going to say, we're calling it 2 different equations. First one is square root, so that's second and then x squared, of 8 minus parentheses x plus 1 plus parentheses squared. Now, notice that the plus 3 is not up underneath the radical. Okay, you can see it on the far right side of your screen at the bottom. So if you are using a graphing calculator that has parentheses here, uses parentheses like mine does, I have to close the parentheses here to say this is the end of where I want the radical to go. I want the radical to stop here. If you are using one where you can see the radical continuing across the top, you have to use a right arrow button to get away from underneath the radical. So either way, you have to get out from underneath the radical now and then hit plus 3. Now in y3, I'm inputting exactly the same thing with a negative out front. Remember to use a negative, which is next to the decimal key, instead of a minus. And we have what we're ready to graph. All right, so I'm going to go to the graph, and I like to go to the standard viewing screen, which says, or standard window, which says, I'm going to press zoom 6 instead of graph. And now I've got my parabola, and I've got my circle, which looks like it has, I was going to say it looks like it has a chunk missing, but it looks like it has the entire bottom half missing. So let's see what happened here. We go back to y equals, and see if I can figure out why. Oh, look at what I did accidentally. 388, not necessary. Okay, now it should show up. So top half of the circle, bottom half of the circle. It doesn't look like a circle, but that's because my screen is not square. Okay, so now we've got 3 pieces of equations, or basically 3 equations. One is the parabola, one is the top half of the circle, and one is the bottom half of the circle. So I have 2 points of intersection. One is right here, that's a solution. The other one is down here. So I have to find those 2 points. Now, what makes this a little bit harder than the last one, the parabola and the line, is that I don't have just 2 things in y equals. I have 3 things. So when the calculator asks me what things I want to find the intersection of, I have to be careful to tell it correctly. So I start out the same way. I press second, calc, and then 5. And now is when I'm talking about the key moments in terms of making that decision. It asks me, what is the first curve you want to find the intersection of the 2 things? So look up here in the left corner. It tells you, okay, right now that's talking about the parabola. Okay, so yes, I want to know where the parabola meets. And now it's talking about the top of the circle. So good. That's fine. I do want to know where the parabola meets the top of the circle. So I'm going to press enter here as well. Now for the guess, I have to make sure I move to the point of intersection at the top of the circle and the parabola, and then press enter, and it's going to give me my answer. So that point of intersection is approximately at negative 2.099, so negative 2.1, and 5.61. So negative 2.1, 5.61. Let's come back over here and say, here are my solutions. This is rounded to the hundredths place. Notice that even though you're going to see a tenths place here, that's still to the hundredths place because it's a 0.10. All right, now back to find the other point of intersection, which is down here. Same keystrokes, second, calc, then 5. This time, when it asks me which curves I want to find the intersection of, I'm going to say the parabola, which is y1, so I press yes, enter. And I am not going to say yes or enter for the top of the circle, which is what it's pointing at right now, and what it says up here. So I have to go over here, and on the arrows, I will press the down arrow once to switch that to y3. So watch up here. Down arrow makes it say, oh, y3, you want this part and the parabola. Yes, I do. So I'm going to press enter. And my guess, I want to move closer to where they intersect. Press enter again. And the point of intersection is negative 1.04 and 0.17. Negative 1.04 and 0.17. And these are my solutions because they are where, and let me just sketch this real roughly here. They are where my parabola meets this circle. Here and right here. And that's all there is to it.